Hi, I am Prakash Venturi from Dino PTS Design and Engineering Solutions. In the video, we discussed about concrete pull-out test. Already, uh, concrete pull-out test is performed experimentally. Now, we are doing the validation, and at the same time, we are doing the simulation using the ABAQUS simulation software. Here, uh, we are taking the material is M30 grade concrete and the steel is ferrous 450. For that pulling purpose, we are using the steel rod, 12 steel rod. Uh, what is the concept is going on here is the block size. Yes, it is an abacus. The block size is 150 and 150 height is 150. Okay, and at one here, uh, it is a block. It is a steel rod is 12 diameter. We have taken as a three partitions in the steel rod. See that is the one here. It one there is a small deviation I provided it here. There is a some gap between the concrete and steel until the 50 and so means it means there is a no bonding between the concrete and steel at bottom of the 50 and the middle 50 is completely bonded with the concrete and again the top portion of the steel rod is again not bonding with unbonding with the concrete. Okay, and at same time at here this is a region we completely constrained as per the experimental setup, and at same time at from here we are applying the pulling load. Now, while the pulling test is going on, pull out test is going on, how the concrete damages and how the tension damages, as well as the like displacement character and the reaction load on the concrete, we are considering. Okay, we are analyzing in this. Okay, fine. Here, for that, we have taken the two parts. One is the concrete material and the steel. For that, I have taken the properties. Is what is the concrete and steel property? For the concrete property, M30 grade, uh, concrete damage plasticity behavior taken. It is the density in millimeters and Young's modulus in millimeters. Concrete damage plasticity parameters and the concrete damage compression behavior, we can see that it is a one is the M30 grade, and after the M30 grade, it is a resistance. We can see it. And next one is here the compression damage parameters also we have given, and next one is tension behavior, tension damage properties also we have given. Okay, fine. And as well as for the steel, in the analysis for steel material are using for only the pull out test only, so that here only elastic properties of the steel material is given, but not given the plastic characters of the steel. Okay, fine. And the next one is it is an assembly. We can see that these are property and the yellow color indicates the steel material, and this is the color is concrete material. And the next one is the assembly we have given, and to applying the pulling force, there is a reference one we have given at the steel member, and reference two is given at the concrete structure. Okay, well, this is the concept. And the next one is the setup and explicit dynamic analysis we have taken, and the time is 0.1 second. And for to move fastly the simulation, I have taken the mass source is 100. Okay, fine. The next one is then there is a historical output is performed at here. And, the one for displacement behavior and towards the y direction, and it is a displacement. Displacement means RF2 is a displacement. And the next one at here we are assigning the action. Action means pulling load. We are assigning is forces, and the reaction force and two is the one here. Okay. Uh, Next. From this one, RF2 for displacement character. Sorry, RF1 RPM is which one? Action one. Okay, right. Next one is we are giving the meshing, and the tetragonal meshing is given. Here, actually, there is a contacting, bonding, and unbonding characters is there. So, between to give the proper bonding as well as complex geometrical shape is yeah, so if the geometry has a and irregular shape, so that I use the tetragonal element shape. Okay, fine. Here, if you're going to the load, in the load, initially like attractions we have provided. In the attraction, RF22 in the phase attraction is there, and the next one is RF1, and some elements I selected. It can show it here. See, it is the one is RF1, and some elements are rigid body connections are applied. While the rigid body connections are applied, if you are applying the reaction load one, if you are applying the any displacement from reference point one, automatically that displacement totally taken up to the selected. And the next one is the constraint two. It is a constraint two, and the upper face of the concrete block is connected to here the reference point. Okay, next one is there is displacement you have given, and the amplitude data is given. Is the value is 3 is okay. And the next one is it is a displacement in case all degree of freedom is defined with this is the support. Okay, done. And the next one is here the job, and job is done. It takes nearly half an hour time to solve the simulation, and after then we can check the results. It is a results. In the concrete damage as along the tension direction, and at the initial point, here we can check that. If you are applying the, see that the number is comes to out. Here we can see that here the column, sorry, it's a bar. Are applying the pull out test. Here the bar comes to up, and at the same time cracks are introducing at the from the center. Okay, like that, cracks are happen. And the tension cracks, these are the, as well as the compression cracks also we are supporting it here, so that some compression behavior, as well as we can see the cut section also, so that it is this is a top view. We can remove some elements at here, and okay, we can see that is the compression damage inside the uh, concrete, as well as tension damage. Also, we can see the concrete object. Okay, here after then for that we are performing, and request also historical data of request also have given, so that there is a historical data. We can see that one is here the reaction force and the spatial displacement is there. And if you click on the reaction force, it comes at the downward direction. So we have to bring the value we have to give. And it is a displacement we are assigning at concrete, sorry, is the steel bar. So for that is the operating XY data. In that, now for the operating XY data, historical data, and okay, and select on that and save as, and off it is the reaction force, RF. RF is the reaction force. And the next one is spatial displacement, and DISP displacement is the okay. And if you are going to operating XY data, we have a displacement RF data. So we have to combine that to in a graph. There is a displacement, okay, and RF means we have to give the minus and reaction force. No, okay, sorry, is the one and comma is required and minus reaction force and save as there is a here RF versus displacement. Okay, if you we can save it. Next one is the select on here displacement and you click on the plot. This is the plot for which one force and the displacement curve for the concrete. Okay, if you give the proper machine, we can get this smooth curve as well as a, if you increase the load step, we can get a smooth curve for the displacement and load curve for the concrete pull out test. Okay, and here the results are properly validated. Okay, if the value properly is validated. Okay, thank you.